Now, we have just been over how we do the substitution. First of all, whether we know g of x or not, if f of x is 1 over x, f of g of x has to be 1 over g of x because x has been replaced by g of x. So we have to replace this x by g of x. And if f of x is the square root of x minus 3, then f of g of x, without any reference to g of x, is simply then replacing x by g of x. Replace this x by g of x, we get g of x minus 3. And g of f of x, again, since g of x is x squared, g of f of x is quantity f of x squared. Replacing that with square root of x minus 3, we get this. And very similarly down here, that's the process. That's our substitution process. Now, let's worry about the idea of the domain. Okay? Because if you look at f of x, not just any number can be substituted for x. You have a square root here, and what's under the square root can't be negative. Okay? So we have to say that, okay, f of x equals this, but there's the restriction that x minus 3 has to be greater than or equal to 0. You can only do a square root of a number if it's greater than or equal to 0. If it isn't greater than or equal to 0, it's negative. Square root of a negative, you can do it, but it's a complex number, and if we're in the domain of real numbers or the range of real numbers, we're talking about functions of real number, real valued functions of real numbers. We don't allow complex numbers. So x minus 3 has to be greater than or equal to 0, and that's easy to rearrange. X has to be greater than or equal to 3. Okay. So whatever we put into f of x has to be greater than or equal to 3. So when you say f of g of x is the square root of g of x minus 3, well, yeah, okay, but there's a restriction. G of x, the thing that we're plugging in, the f function, has to be greater than or equal to 3. And clearly it does. If g of x isn't greater than or equal to 3, you're going to get a negative number here, aren't you? Okay? So now, at this stage, we can write this without knowing what g of x is. We know from the fact that you can only put numbers greater than or equal to 3 in for f of x, that the only values of g of x that can be put in there are the ones that are greater than or equal to 3. Okay? Now, we can use the fact that g of x is x squared. We'll replace this by x squared minus 3. Well, g of x still has to be greater than or equal to 3, so x squared has to be greater than or equal to 3. And x squared is greater than or equal to 3 if, well, you take the square root here. Okay, x would be greater than or equal to the square root of 3. Also, x could be less than or equal to negative square root of 3. Now, we haven't dealt with the reasons you have these two inequalities here, but you can verify that you do. For example, a number that's greater than or equal to the square root of 3 would be 2. Okay? 2 squared is greater than or equal to 3. I'm sorry. Square root of 3 is a little less than 2 because 2 squared is 4, which is a little greater than 3. Anyhow, if x is 2, well then x squared is 4, and this works fine. What if x was less than or equal to negative 3? First whole number that's less than or equal to negative 3 is negative 2, so let's just see if that works. If we put in negative 2, what do we get? Well, the square of negative 2 is 4. We still get 4 minus 3. That's a positive number. So that works just as well as 2 does. And the fact that then when you square a negative number, you square its absolute value. So for all those reasons, all the numbers bigger than 3 and all the numbers less than negative 3, including then also 3 and negative 3, give us squared values that are greater than or equal to 3. So, this is our f of g of x function with this provision that x has to be greater or equal to 3 or x is less than or equal to negative 3. And we could also use this in interval notation. We could say x is a member of the set negative infinity negative square root of 3, union, square root of 3, infinity. Just another notation, okay? Now, we'll do another, yeah, we'll stop this clip right here, and we'll go on and look at what happens to g of f of x, and are there any restrictions on the domain of that function.